Going to do some more SAT prep. This is 3.2.11 on page 521, which is practice test 3, section 2, number 11. Sanai customized her bicycle by exchanging the front wheel, this red one. She exchanged it for a wheel that had 1/2 the diameter of the back wheel. So I called the back wheel's diameter letter D, and I called this one 0.5 D. When Sanaya rides her bicycle, how many revolutions does this wheel do for every revolution of the back wheel? Now, the first thing is, logically, you should be picking a number larger than 1. Because if this wheel is smaller, now I did not draw it to scale well, but if this wheel is half the diameter of this wheel, then as this wheel rotates, like in each rotation, this wheel is going to go pi times this number d. Since this has a smaller distance to go around the edge, in order to keep up and essentially have the same linear distance on the ground, this is going to have to rotate faster. That's how it works. The smaller wheel has to rotate faster. So this is going to do more than one rotation, while this guy does one rotation, which immediately tells you the answers are either A, which is 8, B, which is 4, or C, which is 2. If this seems really abstract when I do it, I'm going to suggest that since they didn't tell you anything about what the diameter is, you just pick really easy diameters and then you try and see how many of this would how many times this would rotate to get this. So we'll do that in a sec. So if you want to do this the abstract way, this blue wheel has one revolution that is equal to 1 of its circumference, right? That's how it works when you circumference, sorry. When you rotate once around, the tire rolls the whole way around and gets back to where it started. So that's 1 circumference, right? So 1 revolution of this guy is d times pi, right? So 1 revolution of this, right, 1 revolution of the red tire would be 0.5 d, because we said that this is half of whatever this d was times pi. So you can kind of see by visual inspection that this would have to happen twice to give you a d times pi. The other way you can see it is you could divide d pi by 0.5 d pi, and you'll get that it would have to occur twice. So again, logically, you could either say, hey, how many times do I have to do 0.5 d pi to get d pi, which would be d pi divided by 0.5 d pi. 1 over 0.5 is a 1 over a 1/2, which is a 2. Or you could logically say, hey, I'd have to do this twice to get this number, because this number is half that number. If either of those things feel uncomfortable, there is another way that you can logically do it. You can just make up a value for the diameter. You can say, you know what, dude, I'm just going to call this guy's diameter 10, which means this guy's diameter is 5. That means this guy's circumference is 10 pi. This guy's circumference is 5 pi. Oh, I would need to do this twice to get 10 pi, so the answer is 2. There's no reason that you can't make up a number if that makes you feel better and if that's a more logical way to do it.